So let's talk about Python basics. No matter what famous programmer you think of, like Bill Gates or Guido van Rossum, they also started at a basic level at some point in their life. These basic concepts are a necessity to build a foundation on which you can learn any programming language. After all, you don't start building a house from the roof down. You need to have a foundation to work from. That's where this week comes into play. The focus this week will be on data types and variables. These are the core concepts in just about any programming language. The beauty of learning a single language is that it allows you to pick up other languages easily. This is due in part that all languages follow the same core concepts. By the end of this week, you'll be able to understand how to write simple programs on your own. A program such as the one that we'll build together, where we will print information out to the user in a nicely formatted receipt. This week, I also introduced your first challenge question. These questions are to ensure that you begin to think like a developer. Some questions may not have definitive answers, but rather, they'll push you to create solutions and problem solve. It's important that you spend some time thinking about each question so that you can begin to train your problem solving skills. After all, it's the most sought after skill in every development industry. So to give you a brief overview of what we'll be doing in this part of the video, we will be understanding data types, how to use variables, seeing what you can do with strings, how to manipulate strings, coding a program that prints receipts. Now let's give you a challenge question. In programming, we have a concept called algorithms. An algorithm is simply just a set of steps. Whether you know it or not, you've used algorithm throughout your life. A common algorithm is a recipe that you follow to make foods. To think like a developer, you must begin to understand how a computer reads code. A computer is only as smart as the program that is supposed to execute. This means that even the smartest computers can fall if the steps aren't correct. Let's use a recipe to bake a cake, for instance. If we miss a single step or leave the cake in the oven for too long, then we fail, as would a computer that is missing a crucial step. Now, I'd like you to think about the steps for making a peanut butter and jelly sandwich. Write down your steps on a piece of paper. Try to think like a computer when you write them out, and understand that you need to be as precise as possible. The answer will be at the end of this chapter. So Monday, we're going to talk about comments and basic data types. Today marks your first lesson of the Python language. The two concepts taught today will help build that foundation that we are striving for. To follow along with the content for today, let's open up Jupyter Notebook from our Python Bootcamp folder. If needed, go back to the last week's lesson on how to open up Jupyter Notebook. Once it's open, create a new file and rename it to week 02. Next, make the first cell of Markdown with the following code. All right, so let's get to it. Let's open up a terminal. Now that we have opened the terminal, let's go into cd desktop, cd python _ bootcamp, and then let's open up Jupyter Notebook. Now let's create a new file and call it and click on Python 3. Then we're going to create a markdown with the following content. Hashtag comments and basic data types, and then press Shift Enter. Now before we do we did that, we needed to change the title to video underscore 02 and rename it like so. Now, what are comments and why we use them? Comments are like notes that you leave behind, either for yourself or someone else to read. They are not read in by the interpreter, meaning that you can write whatever you want, and the computer will ignore it. A good comment will be short, easy to read, and to the point. Putting a comment on every line is tedious, but not putting any comments at all is a bad practice. As you program, you'll begin to understand what that happy medium looks like. When you begin to write larger programs, you'll want to leave notes for yourself. Too often have I created a program, stopped working on it for 3 weeks, and when I came back, I forgot what I was working on. Leaving comments isn't only good for yourself, but also for others who will read your code. Think of comments as breadcrumbs that help you understand what's going on. So, writing comments. In Python, we can write comments using the hash symbol. Any text that follows this symbol will be commented out. In the cell below our markdown header, let's write our first comment. Now let's write, this is a comment. Now let's go ahead and run the cell. Notice that nothing happens. This is because the computer completely ignores any comments. For the most part, we'll write comments on their own line. However, in certain instances, you may see comments written in line with code. In the same cell as the previous comment, let's add the following line. So let's write print hello. The first portion of this line will run output hello, but the second part will be ignored because of the hash symbol. So let's run it and see what happens. There you go. Note, Markdown uses hash characters for headers, like Python comments. Make sure you know what type of your cell is set to markdown/cell. To write multi-line comments so that you may write more descriptive paragraphs for larger portions of code, we would need to use 3 opening and closing double quotes. So let's try this and type in 1, 2, 3, and then press enter and then enter again, and then this is a multi-line comment. Now let's print hello again. And then write a comment. This is also a comment. Now let's go ahead and run the cell. So press Shift Enter. Notice that the text within the multi-line comment gets ignored. These types of comments are great for adding descriptive paragraphs about your code. Be sure not to overuse them. However, as you can certainly make a mess of a program by using too many of them. So, now on to the important part. What are data types? Almost all languages use data types. They are essential to every program. Data types are how we define values, likes, words, or numbers. If I were to ask you what a sentence is made up of, you would probably reply with words or characters. Well, in programming, we can call them strings. just the same as we refer to numbers as their own data types as well. Data types define what we can do and how these values are stored in memory or on the computer. So let's go ahead and open up a google.com page. Now that we are in Google, let's look at data types in Python. So let's open up this one, for example, and see what it's about. That's very small. Let's try another one. Now let's look up for a more accurate one. As we look for a suitable one, we try to make sure that it explains all data types in Python. So let's explain this one, for instance. Now let's open the image in a new tab. Now that we can see it clearly, let's explain this. Data types in Python are divided into basic sets: numeric, integer, float, complex number. So integer is a whole number, for example 5. Float is a decimal number, for example 5.7. Now we have a Boolean. A Boolean is either true or false. Also a string. This is a sequence type, and a string can be characters within codes. Now for the other data types, we will be explaining them in depth in our next video or part of that video. Now on to the print statement. Before we go any further, I just want to touch on the print statement. In almost every language, you need the ability to output information to the user. Within Python, we're able to do this through the print statement. Now, I don't want to get too far in depth, but the print statement is what we call a function in Python. We will cover functions during the entire 5th week. For now, though, just know that the print statement allows us to output information to the user. The way it works is by writing the keyword print followed by parentheses. Whatever is inside of the parentheses will be output for the user to see. Now let's talk about integers. These data types are often called integers or ints. They are positive or negative, whole numbers, with no decimal points. Integers are used for a variety of reasons. Between math calculations and indexing, which we will get into later, they are a main data type in any language. Let's go ahead and print a couple of examples out in the next cell of our file. The following are all integers. Now print 2, that's an integer. Print 10, that's also an integer. Now let's run it. 2 and 10. Floats. Anytime a number has a decimal point on it, they're known as a floating point data types. It doesn't matter if it has 1 digit or 20, it's still a float. The primary use of floats is in math calculations, although they have other uses as well. Let's check out an example. The following are all floats. So let's type in a couple of floats right here. Print 10.935. Print 6.231. These are all floats. And also print 8.0, which is also a float. Now let's run this cell. Note that the number 8.0 is considered a float because it includes a decimal point. Now let's talk about Booleans. The Boolean data type is either a true or a false value. Think of it like a switch, where it's either off or on. It can be assigned any other value except for true or false. Booleans are a key data type, as they provide several uses. One of the most is for tracking whether something occurred. For instance, if you took a video game and wanted to know if a player was alive, when the player spawned initially, you would set a Boolean. You would set a Boolean to true. When the player lost all their lives, you would set the Boolean to false. This way, you can simply check the Boolean to see if the player is alive or not. This makes for a quicker program rather than calculating lives each time. Let's go ahead and run the following. Now, this is a Boolean. These are all Booleans. Now print true and print false. Now let's run this out. True and false. Strings, also known as string literals. These data types are the most complex of the four that we'll go over today. The actual definition of a string is, strings in Python are arrays of bytes representing Unicode characters. To most beginners, that's just going to sound like a bunch of nonsense. So let's break it down into some simple concepts that we can understand. Strings are nothing more than a set of characters, symbols, numbers, white space, and even empty space between two sets of quotation marks. In Python, we can use either single or double quotes to create a string. Most of the time, it's personal preference, unless you want to include quotes within a string. So if you want to include quotes within a string, you will need to use a double quote, and then a single quote. We will show this by an example. Whatever is wrapped inside of the quotation marks will be considered a string, even if it's a number. Let's go ahead and write some examples in the next cell for strings. The following are strings. Print nothing, and that is a string. Print there's a snake in my boot. Print true as a string. The output will include an empty line at the top as we print out nothing in the first statement. Now let's run it. As we can see, this is exactly what happens. Now let's go on to a simple exercise. I want you to learn output. So please try to print out your own name. And also, let's try type checking. Try checking the type of a value by using the type method. This will always print out what kind of data type you're checking. This is useful to check data types when you are unsure, as an example. Now pause the video and try to do both of these tasks. Alright, so let's start printing out my name. Print Moataz Hassan, and then type Moataz Hassan. That is a string. Now let's try type 2. That is an integer. Now let's try type 7.0. That is a float. Now let's type. Let's find out what the type of true is. That is a Boolean. These are all the types that we've already learned. As you can see, like so. Today we focus on the 4 essential data types in Python. Understanding the difference between each is key as we move forward. In tomorrow's lesson, we will begin to understand how to save these data types to be used later in the program. Now let's go on to variables. Variables are one of the most important beginner-level concepts in programming. They allow us to save values into memory using a name that we assign. This lets us use those values later in the program. Yesterday's lesson covered different data types. But what if we wanted to save one of those data types to use later? This works like how we store information in our brain. Variables are stored in computer memory, and we can access them later by referencing the name we used. I won't go into the theory behind how Python stores information, as we're focusing more on the application of programming. But it's worth noting that Python automatically handles memory storage and garbage collection for us. To follow along with this lesson, let's continue from our previous notebook file, video 02, and simply add a markdown cell at the bottom that says variables. So how do they work? We declare a name on the left side of the equals operator. And on the right side, we assign the value that we want to save to use later. Take the following example. First name equal John, like so. Like so. And that is a simple variable. When you create a variable, the line where you assign the value is a step called declaration. We've just declared a variable with the name of first name and assigned it the value of the string data type John. The string is now stored in memory, and we're able to access it by calling the variable name first name. Variable names can contain only letters, underscores, and numbers. However, they cannot start with a number. So for instance, if we try to create a variable name like this one and see what happens, it's going to give us an error. Handling naming errors. All programmers make mistakes, so it's not a problem if you run into errors. It just comes with the job. Let's look at common mistake that occurs with variables. No need to write. But I'm going to write this to explain it. So let's just type in sport equal baseball. Capital S. And then Now this is incorrect. Now let's try print sport with lowercase s. Let's try and run this. Now we get an error because the name sport is not defined. This is because the names are completely different. We referenced a variable with a lowercase s, but declared one with capital S. To fix this, we would capitalize the S in the sport within print. So let's type in sport equal baseball, and then sport equal, sport equal baseball, and then print sport with a capital S. Sport equals baseball, and then print sport. There you go, baseball. Now let's talk about integer and float variables. To store an integer or float in a variable, we give a name to the left of the operator and write a number on the right side. In the next cell, let's go ahead and write the following codes. num1 equals 5. num2 equals 8.4. Print num1 and num2. Now go ahead and run that cell. Notice that the output is 8 and 8.4. Even though we print out num1 and num2, we're printing out the value that is stored in those variables. Now let's talk about Boolean variables. Remember that Booleans are true or false values, so storing them is as simple as typing in one of those words. Now let's write the following. Storing a Boolean into a variable. Name John Smith. Favorite number equals 9. Now let's print a variable. We will go over this in the next cell. So we're just going to have switch equal true, and then print switch, and then run. And there you go. We have switch and we have true. Now let's store strings into a variable. Now let's try name equals John Smith, and favorite number is 9. Now let's print name and favorite number. This will print 9 next to the name. Now let's go ahead and run this. And that's it. Now using multiple variables. Let's try to use multiple variables. Using two variables to create another variable. Result equals num1 plus num2. Print results. In almost any program, you're going to need to perform some calculations or manipulation on variables. In the following code, we access the values from previously declared variables and add them together to create a sum. Make sure that the previous cells have been run before running this cell. Let's go ahead and put this in a new cell. Now let's try to run this and see what happens. Now we get 13.4. That's very strange. Where did this come from? Well, please remember that we first declared num1 is equal to 5 and num2 is equal to 8.4. So 5 plus 8.4 is 13.4. Now, using operators on numerical variables, think of Python as a calculator where we can alter any variables we want. In the following code, we alter the result variable defined previously. So let's try adding, deleting, multiplying, dividing from a variable. Result plus equal 1. This is the same as saying result equal result plus 1. Now print result. Now let's try to say result equals result times 1 times num1. This is the same as saying result equals result times num1, which is 5. Now print result again and run the cell. Now we get 14.4 and 72 as two floats. So to explain this again, in the first line we added 1 to the result. Then later we multiplied it by the value of num1, which is 5. All that while the computer saved the result variable so we could continue to edit it. Then we print the result again, which comes out to 72.0. So overwriting previously created variables. Python makes it easy for us to change the value of a variable by simply redeclaring it. In some languages, you would have to define the data type, but Python handles all of that for us. We've seen this occur with the preceding result variable, but it's worth noting in its own cell. Defining a variable and overwriting its value. Name John. Let's print the name. Name Sam. Let's print the name again. So let's try doing this. Defining a variable and overwriting its value. Name equals John. Print name equals Moataz, print name. Let's go ahead and run this. John and Moataz. To follow along with this lesson, let's continue from our previous notebook file, video 02, and simply add a markdown cell at the bottom that says working with strings. Now, string concatenation. When we talk about concatenating strings, I mean that we want to add one string to the end of another. So this concept is just one of many ways to add string variables together to complete a larger string. For the first example, let's add 3 separate strings together. Using the addition operator without variables. Name equals Moataz plus space plus Hassan. Now print name. And there you go. We ended up adding 2 strings that were names and separated them with the use of a string with a space inside. Now let's go ahead and try to store the 2 names into variables first. Using the addition operator with variables. First name equals to Moataz. Second name, last name equals to Hassan. Full name equals to first name plus space plus last. Now print full name. And there you have it, Moataz Hassan, using the addition operator with variables. Now let's talk about formatting strings. Earlier, we created a full name by adding multiple strings together to create a larger string. While this is perfectly fine to use, for larger strings, it becomes tough to read. Imagine that you have to create a sentence that uses 10 variables. Appending all the 10 variables into a sentence is tough to keep track of, not to mention read. We'll need to use a concept called string formatting. This will allow us to write an entire string, inject the variables we want to use in the proper location. Now let's also talk about the dot format method. The dot format method works by putting a period directly after the ending string quotation, followed by the keyword format. Within the parentheses after the keyword are the variables that will be injected into the string. No matter what data type it is, it will insert it into the string in the proper location. Which brings up the question, how does it know where to put it? There's where the curly brackets come into play. The order of the curly brackets is the same order for the variables within the format parentheses. To include multiple variables in one format string, you simply separate each by a comma. Let's check out some examples. Injecting variables using the format method. Name is equal to John, or let's call it Moataz. That's my name. And then print hello dot format name let's try to print hello curly brackets you are years old dot format name 28. Now let's go ahead and run this out. Now we got an error. Now let's try to fix this error. Now in order to fix this error, you just need to clear out these spaces and then execute again. That's it. Keep in mind that the format function will inject variables and even data types themselves. In this instance, we injected the integer value 28. So let's talk about f-strings. This is new in Python 3.6. The new way to inject variables into a string in Python is by using what we call f-strings. By putting the letter f in front of a string, you're able to inject a variable into a string directly in line. This is important as it makes the string easier to read when it gets longer, making this the preferred method to format a string. Just keep in mind you need Python 3.6 to use this, otherwise you'll receive an error. To inject a variable in a string, simply wrap curly brackets around the name of the variable. Now let's look at an example. Using the new f-strings. Name equals Moataz. Print f hello name, and that's it. It's all you need to do. Now let's run the program. There you have it. Hello Moataz. Please note that throughout this course, we'll be using the dot format method instead of the f-string. Formatting in Python 2. Python 2 doesn't include the dot format method. Instead, you would use percent operators to mark the location of the variable being injected. The following is an example to inject the variable name into the location S. The letter after the percent operator signifies the data type. For integers, you would use D for digit, After the string closes, you will place a percent operator, followed by the variables you would like to use. Let's look at an example. One major difference between versions 2 and 3. Name is equal to John. Print hello. Now let's try to run this in Python 3. One major difference between versions 2 and 3. Name equals Moataz. Print hello s. Name. Let's go ahead and run that. Hello Moataz. Now this works. This also works in Python 3. You'll notice that we get the same output as the previous methods. If you wanted to format a string in Python 2 with multiple variables, then you would need to write the following. Python 2 multiple variable formatting. First equals Moataz. Last equals Hassan. Print hello s. First, last, and that's it. Surround the variables in parentheses. This is short for string. And let's run this. Hello, Moataz Hassan. Now when passing multiple variables, you need to surround the variable names within parentheses and separate each by a comma. Notice there are also two symbols within the string that represent the location of each respective variable in order from left to right. So string index. One other key concept that we need to understand about strings is how they are stored. When a computer saves a string into memory, each character within that string is assigned what we call an index. An index is essentially a location in memory. Think of an index as a position in line that you're waiting in at the mall. If you were at the front of the line, you would be given an index number of 0. The person behind you would be given index number position 1. The person behind them would be given the index position 2, and so on and so forth. So indexing in most languages, including Python, starts at 0 and not 1. The same is true for Python strings. If we take a string like hello and break it down their indices, we can see that the letter H is located at index 0. Let's try example. Word equals hello. Now let's print word index of 0. This will output h print word index of 1, and this will output e. Now let's print word index of 2, and this will output e. L print word -1. This will output O. Now, in order to index a specific element, you use square brackets to the right of the variable name. Within those square brackets, you put the index location you wish to access. In the preceding case, we're accessing the first two elements in the string hello, stored in the variable word. The last line accesses the element in the last position. So -1 is equals to the last position. Using negative index numbers will result in trying to access information from the back, such that -4 would result in the output of the letter E. So this is index 0, index 1, index 2, index 3, index 4. This is index -1, -2, -3, -4, and -5. Be very careful when you're working with indices. An index is a specific location in memory. If you try to access a location that is out of range, you will crash your program because it's trying to access a place in memory that does not exist. For example, if we tried to access index 5 on the hello, we would get an error. Now let's talk about string slicing. I want to just quickly introduce the topic of slicing. Slicing is used mostly with Python lists. However, you can use it on strings as well. Slicing is essentially when you only want a piece of the variable, such as that if I only wanted he from the word hello, we would write the following. Print word 0 and 2. And that's it. The output will be HE. The first number in the bracket is the starting index. The second is the stopping index. We will touch on this concept in a later week. However, feel free to mess around with slicing. Before the day ends though, I'd like to quickly cover the start, stop, and step arguments when slicing. The syntax for slicing is always variable name, start, colon, stop, colon, step. In the previous cell, we only included, so it's written like this. So let's create a markdown just to explain what this is. Variable name, and then square brackets, and then start, stop, step, and that's it. Now, let's print the start of the string of words and the fifth and the fourth index of words, and then the second step of the word hello. Let's try this. Print word start is going to be 0, then 5, then 2. This will output HLO. So let's print it out and see what happens. Sorry, I made a mistake. It's 2 and not 3. And that's it. So go ahead and run the cell. By passing this step as the number 2, it increments the index by 2 each time instead of 1. We will cover this more in depth in a later chapter. For now, let this be an introduction to slicing with all 3 arguments. So now, let's try to do 2 exercises. The first one is variable injection. Create a print statement that injects an integer, float, boolean, and string all into one line. The output should look like this. 23 4.5 false John. So the output should look like this. 4.5 false John. Now, in order to print all of this in just one line, what would you do? Now let's try this my way. Pause the video now and try it yourself first. Now in order to print this, we just type in Now, in order to print this, we just type in num1 equal 20, number 1 equal 23, number 2 equal 4.5, switch is equal to false, and name is equal to John. Now in order to print all of these in just one statement, let's try to do it with the .format function. We're just going to go ahead and type in print, and then squiggly brackets, squiggly brackets, squiggly brackets, and other squiggly brackets. Then format, and then number 1, number 2, switch, and name. Now let's see what happens. There you have it. 23, 4.5, false, and John. Now for the second exercise, which I also want you to pause while working, I want you to fill in the blanks. Using the format method, fill in the following blanks by assigning your name and favorite activities into variables. So I want you to change this with your name and your favorite sport, and also your name and which language you're working with right now. So we're just going to show you what you need to do. we're just going to create a markdown and then type in quotation marks, then squiggly brackets, and other squiggly brackets, and then favorite support is squiggly brackets and dot. Now also, I want you to type in squiggly bracket is working on squiggly bracket programming. Now let's try this and see what happens. So name is equal to Moataj, sport is equal to soccer, and language is equal to Python. Now let's print the following statement. Dot format name dot format name and sport. Now also I want you to print the following. Print is working on now let's complete it. Dot format and then and that's it. Now let's execute. And there you go. We covered some key concepts when working with strings today, formatting and indexing. Tomorrow we'll use our methods that will help us manipulate strings. So in many programs that you will build, you're going to want to alter strings in one way or another. String manipulation just means that we want to alter what the current string is. Luckily, Python has plenty of methods that we can use to alter string types. To follow along, let's continue from our previous notebook file, video 02, and simply add a markdown cell at the bottom that says manipulating strings. Now let's add manipulating strings to a markdown that says so. And that's it. Now let's start with dot title. Often you run into words that aren't capitalized that should be usually names. The title method capitalizes all the first letters in each word of a string. Try the following. Name equals Moataz Hassan. Print name dot title. There you have it. This method is great for formatting names correctly. Try using name.lower and name.upper and see what happens. So print name.lower and see what happens. Print name.upper and see what happens. That's all you need to know with these certain functions. Now dot replace replaces something with something, obviously. So the replace method works like a find and replace tool. It takes into two values within its parentheses, one that it searches for and the other that it replaces the search value with. So replacing an exclamation point with a period words is equal to hello there, and print is words dot replace and then exclamation mark and then a dot. So we want to add a dot or a full stop or a period at the end of the sentence instead of an exclamation mark. So let's try this. There you have it. Now it functions properly. For the replace to be stored properly afterwards, we would have to redeclare our words variable words equal words dot replace exclamation mark comma dot. So let's explain this. If we want to print words with the replaced item, then we should write this: words equals words dot replace and then exclamation mark and then periods. That's it. Now if we try to print words, it'll give us hello there again. Now the find method will search for any string we ask it to. In this example, we try to search for an entire word, but we could search for anything including a character or a full sentence. So let's try finding the starting index of our search term. Finding the starting index of our searched term. To do this, we're just going to say declare a variable called s equals look over that way. And to do this, we have to type in print s.find and then the index of over. Now let's print this out and see what happens. You get a 5. You'll notice that we got an output of 5. Find returns the starting index position of the match. If you count where the word over begins and the O is at index location 5, this is important when you want to access a specific index on a search. So this is basically the find method used in Python. So if you want to know which one is this and why it's a 5, you just count 1, 2, 3, 4, and 5. That's why it's a 5. Also, we have the dot strip method. In cases where you want to get rid of a certain character on the left and the right side of a string, you would use the strip method. By default, it will remove spaces. Let's try running the following. Removing white space with strip. Name equals Moataz and print name dot strip. Now let's try this, and as you can see, there are no spaces. Now try to use the L strip and R strip and see what happens. Print name dot L strip. This removes the space on the left. As you can see, there is a space right here. On the right, and print name dot R strip removes the space on the right. Now let's talk about the split method. I won't go into too much detail with split simply because what it turns is a list and we haven't covered those quite yet. However, I want you to see how to use this method. What it does is separate the words in the sentence into a group of words stored within a list. Now don't worry about this just yet. We'll get there. For now, let's just see how this method works. Converting a string into a list of words. S equals these words are separated by spaces. Now let's try to print S dot split parentheses and then specify which we want to split and see what happens. Now the split here is the space. So let's see what happens. Now we have a list that contains these words are separated by spaces. Now let's start with the exercises. I want you to uppercase something and I want you to strip symbols from something. So in order to solve this, I want you to try to manipulate a string so it puts out all uppercase letters. And then I also want you to strip the dollar signs from the left side of a string that I will give you. You can try it with lstrip and strip. To see a description on how to use strip method further, try using the help function in Python by typing help parentheses and then quotation marks space between them dot strip and then close the parentheses. Now, as I showed you before, in order to capitalize something, you have to use the uppercase method. So in order to do this, we just want to print name dot upper, and that's it. Now the string here try with a different string. I'm just going to call it K equals uppercase, and then print K dot upper, like so. That's it. Now, if you want to strip the symbols from a certain string, like this one for instance, montage or 145. Let's try this. Now, string equals, no, let's not choose string. Word to equals $2 145. Now print these word to with a left strip, word to dot L strip. And then we have to specify this. We can just use strip instead. L strip Now, in order to use the strip function properly, you just need to do this. And that's it. First, now in order to understand what's going on here, the \T stands for the tab indentation. So it's equals to 4 spaces in Python. And the \N is a new line. So let's go ahead and display the product info. Print out header for section items. Print tab product name tab product price. Now let's create a print statement for each product. and then print \t dot format p2 underscore name dot title, and then p2 underscore price. Now let's also print t dot format p3 underscore name dot title, and then p2 price, p3 price. Go ahead and run this cell. We're using similar styles as the previous print statements in order to center each product's title and price under their respective headers. Try not to get too confused by all the symbols within the print string. You can simply break them down to a tab, followed by the first variable being formatted into the string, followed by two tabs, followed by a $sign in order to make the price look like currency, and followed by the second variable being formatted into the string. This completes the section for our items, so let's put another section divider. So let's fix this. We need two tabs and a $sign. Let's copy and paste this. Two tabs and a $sign. Two tabs and a $sign. And there you have it. Very small, very short and simple. Now let's print a line between sections. In order to do this, we're just going to copy and paste it right here. Now displaying the total. Like the products section, we want to create a header for our total, but we want to also center it underneath the price column of the products section. To do so, we'll use three tabs. So let's print out header for section of total, and then print three tabs and total afterwards. Now go ahead and run the cell. Now that we have our total header aligned with the price column in products, we can output our total on the next line. Before we can print out a total, however, we must first calculate the total, which is the sum of all our products. Let's define a variable called total and then print it out. Total equals P1 price plus P2 price plus P3 price, and then print, and then quotation marks, 3 tabs, $sign, and then curly brackets. Now for the formatting. And that's it. Now let's not add another line between sections. Now let's display the ending message. To display the final thank you message, our design has it spaced out slightly more than any other section. So we'll need to add a couple of new lines to give it some extra spacing. So output thank you message. I'm just going to go ahead and print and T and dot format message. Now last but not least, let's print out another line between sections. And let's execute and see what happens. There might be some errors which can be fixed, but that's okay. So on line 4 we have an error that says invalid syntax. Okay, so let's fix it. Now let's fix it. The reason why this returned an error is because we had 3Ds in address. So we just do this and it should work. So let's execute. And then execute. Alright, so we had a couple of bugs actually in our program. The first one is we were missing a parenthesis, one of the parentheses here, and the second one was right here. And after I did both of these, it just worked correctly. Now let's continue with the exercises and the challenges for today's project. This week we went over some very important foundational concepts in programming with variables and working with strings. You must always keep in mind that variables need to be declared before you can use them, and that the name associated is saved in memory with the value on the right side of the equals operator. Strings are easy to work with in Python, as the language has a variety of methods that we can call in order to do the work for us. At the end of the week, we were able to build a simple receipt printing program. Try breaking the program. I always encourage students to try and break the programs because it will teach you how to fix it. Now, challenge question solutions. There isn't a definitive solution to making a P, B, and J sandwich, but I want you to go back and see if you weren't specific enough. Computers are only as smart as we programmed them to be. So if you said to put the peanut butter on the bread, it may just interpret it as putting the entire jar on the bread instead. As a developer, you need to be specific with your descriptions. Even try rewriting a new algorithm with improved steps. Now for the weekly challenges. To test your skills, try these challenges. First challenge, side borders. In Friday project, we ended up creating borders above and below the information printed out. Try adding a star border on the side as well now. Now pause the video and try to do it yourself. Now in order to add the border, you just need to add a star at the end of each line and try to align it using \T or tabs in your receipt. That should take some time, but it should be very easy to do. Now for the next exercise, declare a variable equal to hello, reverse the screen using slicing. So let's declare a variable called hello, name, let's just say word equals hello. Now we want to reverse this. Now in order to reverse a string, you just type in print and then word and then open square brackets and then type in 2 colons and -1 as the last index. And that's it.